So hello and welcome to another video in our Basics of Geometry series. Today I'm going to be talking about something called fundamental properties. See, when we discuss any geometric shape, then when we list down the properties or try to understand what properties stand true for them, then we'll come across this term oftentimes fundamental properties. Now, what is the meaning of fundamental properties? Let me explain with a proper example because people often get this wrong. So let me take the case of a parallelogram, right? So definition of a parallelogram is that it is a quadrilateral in which both pairs of opposite sides are parallel to each other. So let's say that I've got a quadrilateral ABCD in which the side AB and the side CD are parallel, and the side AD and the side BC are parallel, then ABCD will be referred to as a parallelogram. Now, this is a definition. This is not a property. A definition of a parallelogram is that it is a quadrilateral in which both pairs of opposite sides are parallel to each other. It is like saying that a triangle is any geometric area enclosed by three straight lines. So that is not a property, that's a definition. Now, all parallelograms have three fundamental properties. So what are the fundamental properties? You might have heard of this. First one among them is that in all parallelograms, opposite sides are equal. Opposite sides are equal means AB's length will be equal to CD's length, AD's length will be equal to BC's length. Second property, which is true for all parallelograms as well, is that the opposite angles are equal, which means angle A and angle C are equal, angle B and angle D are equal. The diagonally opposite angles are equal. And third property is that in a parallelogram, the diagonals bisect each other. So diagonals bisect each other means if we join the two diagonals, let's say that if I join the diagonals AC and BD, and suppose they intersect each other at the point O, then O will be the midpoint of both AC and BD. So this essentially implies that AO will be equal to OC and BO will be equal to OD. So diagonals bisect each other means that the diagonals intersect each other in such a way that they divide each other into two equal halves. These are the three fundamental properties of all parallelograms. So what does it mean when I say these are the fundamental properties? What I mean by fundamental properties is that each of these properties will be true only for parallelograms, not for any other type of quadrilaterals. It will not be true for any other type of quadrilateral apart from a parallelogram. It will not be true for a trapezium. It will not be necessarily true for a cyclic quadrilateral. Only for parallelograms are these three properties true. Also, the second thing that it implies is that every one of these properties are in itself evidence of the existence of a parallelogram. Again, each one of these properties is an evidence of the existence of a parallelogram, which means that even if one of these three properties is true, we should know that the quadrilateral in question is definitely a parallelogram. So if a question tells you that ABCD is a quadrilateral in which both pairs of opposite sides are equal, that implies that the given quadrilateral is a parallelogram. It cannot be anything else because a fundamental property is true. So if one fundamental property is true, that is enough for us to conclude that it is that quadrilateral for which this is a fundamental property. So if one of these three properties is true, that means that the given quadrilateral is a parallelogram. If one of these properties is true, that means that automatically the remaining two properties will also be true. Oftentimes students will ask me that, sir, the question only tells us that opposite angles are equal. It does not tell us that both pairs of opposite sides are parallel. And that's why we cannot conclude that it is a parallelogram. So I replied to them that that's not how fundamental properties work. Opposite angles are equal is a fundamental property. So if opposite angles are equal, it means that the given quadrilateral is a parallelogram, nothing else. Now, if you understand this, but you're also confused with the fact that, but opposite sides are equal for a rectangle as well. Opposite sides are equal for a square as well. Opposite angles are equal for a square as well. So why are we saying that it will only be a parallelogram? Why not a rectangle? Why not a square? If you have that question, then watch the next video in the series of geometry concepts. Thank you.